Hello guys, Mr. G here, and we're going to be doing another video on stoichiometric. In this time, we're going to be talking about molar volume of gases, and maybe if there's time, we'll speak about concentration. In the previous one, we spoke about the mole, the definition of the mole, and we did some calculations regarding the mole. So let's go to the molar volume of the gases. Now, what is the first important thing you need to know? Okay, so that is that at the same temperature and pressure, the volume of a gas of gases are directly proportional to the number of moles of the gases present. Now, what does it mean? Okay, what does it mean? Let's say we have this reaction of hydrogen and nitrogen to produce ammonia. Okay, so now note that all of them are in gas. All of them are in the gas state. Okay, now let's record that these numbers at the front, this one's here, the 3, in this case is a 1, you don't write it, and there is a 2. That is the ratio. That represents the ratio. It means that 3 moles of H2 will react with 1 mole of N2 to produce 2 moles of NH3. That is the ratio. The numbers at the front represent the ratio. 1 mole of hydrogen need to react with 1 mole of nitrogen to produce 2 mole of ammonia, and this ratio is very, very important in this stoichiometric calculation later on. Now, what do we just say about gases? If all of them are gases, like we have here, this is a gas, this is a gas, and this is a gas. All of them are gases. Then the ratio does also work for the volume. So we can say that 3 volume, I'm going to write volume, but volume could be in cubic decimeters, or it could be in centimeter cubic, or could be in millimeter cubic. Okay, it doesn't really matter. What I mean is that the ratio must be accurate with the same number with the same volume that we are using. Okay, so 3 volume of hydrogen will react with 1 volume of nitrogen to produce 2 volumes of ammonia. All right, if it's in decimeter cubic, then obvious everything must be in decimeter cubic. For example, what I mean with that one, if you have 3 decimeter cubic of hydrogen, you need minimum 1 cubic decimeter of nitrogen to be able to produce 2 decimeter cubic of nitrogen. This is a very useful statement here. So make sure you learn this one because it is very important. And then here is the explanation. You can use the ratio straight for the volume. You don't have to calculate first volume on anything. You can use the ratio straight if everything is in gases and obviously the temperature stay constant. Okay, so now we're going to move to a law. Now this law is called Avogadro's law, and it's nothing to do with the number of Avogadros that we learned before. Okay, now Avogadro's law. Now what Avogadro's law say? Say that 1 mole of any gas, 1 mole here of any gas occupies the same volume at the same temperature and pressure. That is very, very important and is straight related to what we said here. Okay, so 1 mole of any gas will occupy the same volume. Now, if the temperature is 0 degrees Celsius, which is equivalent to 273 Kelvin, right? And the pressure is equal to 101.3 kilopascal, we say that this is called STP. Very important. Now, what does STP mean? Now, STP means standard temperature and pressure, and is very important. Now, calculations were done to know that if the temperature is 0 degrees Celsius and the pressure is 101.3 kilopascals, then the volume of 1 mole of any gas will be equal to 22.4 cubic decimeters, and this is called molar volume. That is only if we have STP, only at STP. Okay, so that is the molar volume. If, I'm going to repeat this one, if the temperature is 0 degrees Celsius and the pressure is 101.3 kilopascal, which they are standard pressure and temperature, the volume of 1 mole will be equal to 22.4. This is volume of 1 mole of any gas. Only if we are at STP. All right. Now, from here, we have another formula for number of moles. And then we say that the number of mole is equal to volume of a gas divided by the molar volume of a gas. All right. This is molar volume. Now, molar volume doesn't need to be 22.4. Please be careful. It's only 22.4 if there is STP. Okay? Molar volume, volume of 1 mole. This is volume, and this is number of mole, but you already know that. Now, this formula can only be used for gases. Only for gases. You cannot use this formula for anything else but gases. Okay? And Vm is equal to 22.4 only if it's STP. Only at STP you see there on top. So please be careful. Stop the video, go back, move, so you make sure you understand. So if the question doesn't say STP, then the volume, the molar volume, cannot be substituted as a 22.4. Okay? So saying that, maybe we can see a very small calculation of STP. All right, so let's look at one example. Calculate the number of atoms in 20 decimeter cubic of chlorine gas at STP. Okay, so now let's remember that chlorine gas is Cl2, so it's a diatomic molecule. Okay, this is a molecule, and this is diatomic. You have 2 atoms of the same type. Okay, so now let's see. We are looking for the number of atoms. If we recall from the previous video, you know that the number of mole is equal to number of particles divided by number of Avogadros, or Avogadro's number. So from here, if you rearrange, you have that the number of particles is equal to number of mole multiplied by Avogadro's number. Okay, this here, my lovely children, this one here is going to be the number of molecules. Why molecules? Because we are dealing with molecules. So that is why from this formula, what we are going to get is the number of molecules, no atoms. Remember, they want atoms, but with this formula, we are not going to get the number of atoms. We are going to get the number of molecules first. Okay, now what you need to know, each molecule here, each molecule will have 2 atoms. You have 2 atoms of chlorine. So first, we don't have the number of mole. So let's calculate the number of mole. There is a gas and it is at STP. So to do that, we can come and say number of mole is equal to volume divided by molar volume. Okay? They're telling us that the volume is 50 decimeter cubic. So this is equal to 50 decimeter cubic divided by 22.4. Why can I use 22.4? Because it is telling me in the question that this is happening at STP. All right. So saying that, when you calculate this one, you will get 2.23 mole. Okay. You will get 2,23 mole. Now, this 2,23 mole is what we are going to substitute there to get the number of molecules. So let's go there. We have the number of particles, which in this case is molecules, is equal to 2,23 multiplied by Avogadro's number. Please go to the table of constants you have from the school or watch the previous video. It is multiplied by 6,022 times 10 to the 23. Now this will be equal to 13,44 times 10 to the 23. This is molecules. We have that number of molecules. That is the answer for molecules, but that's not the final answer. The final answer, they want atoms. So we know that every one molecule has 2 atoms. So all we have to do is to multiply this number by 2. So you get now number of, I'm going to write atoms. It's going to be equal to 13,44 times 10 to the 23 times 2. Why 2? This is molecules, number of molecules, because chlorine is a molecule. So with this formula here, what you calculate is the number of molecule. But every one molecule have 2 atoms. That is why when you have the number of molecules, you multiply by 2 and you will get the number of atoms. So this is going to be 2,69 times 10 to the 23 atoms. There is the final answer. This, my lovely children, is what they want at the end, number of atoms. Okay, so I hope this one was clear. It is not that difficult. It is, you will be able to do it. Okay, so guys, this is all regarding volume of gases. In the next video we're going to do concentration. I don't want to do it in this video, otherwise it may be a little bit long. I hope it helped. I'll try to make the other video as soon as possible because you're writing very soon and you need the video. This topic is a very important topic, the whole stoichiometric it is. But thank you for watching. Please write comments, ask questions. You can suggest anything you need. And thank you for watching. I'll see you next time.